This question is related to linear programming. Here the profit on a product is changed and we are interested in seeing whether that change will affect the optimum product mix or not. Read this question carefully. Data from that problem has been put in tabular form here. The two products are product A and B. The profitability given as 350 rupees per unit and 450 rupees per unit for product A and B. The raw material requirements for product A 50 and 30 and for product B 30 and 60. Availability of raw material 1 and 2 given here as 1500 and 1800. The linear program is formulated here. Objective function is 350x plus 450y and we want to maximize that. Subject to the two constraints posed by raw material 1 and raw material 2. That linear program has been put in the graphical form here. The feasible solution space is given here. The two technical constraints 50x plus 30y less than equal to 1500 and 30x plus 60y less than equal to 1800. X greater than equal to 0 and y greater than equal to 0. All these four constants are satisfied by the points lying in this space. This is called feasible solution space. You know that the optimum solution will be at any of the extreme points of this feasible space. The extreme points are point 1, which is 0, 30, point 2, which is 0, 0, point 3, which is 30, 0, and point 4, which is 17, 21. You can pause the video time to time and do all these things on your own. Maximum profit will be given by one of these 4 points. In some special case, if the objective function becomes parallel to any of the constant, then you can have multiple solutions. That we will see later. But right now, the maximum profit you will be getting at these extreme points. If the profit on product A is 350 and the profit on product B is 450, then for all the 4 extreme points we have calculated the profit value and we are getting that as 13,500, 0, 10,500 and 15,400. So the optimum solution is 1721. That is, if you produce 17 units of product A per day and 21 units of product B per day, then you get the profit 15,400 rupees per day, which is the maximum out of the 4. You cannot get better profit than this. This is the closest to the maximum. The question says that the profit on product B is changed from rupees 450 units to rupees 600 units. Will the optimum product mix change? That is what we want to find out. Profit on product A remains the same, that is 350, and profit on product B, this 450 changes to 600. The maximum profit will still be at one of the extreme points. So let us see, if this 450 becomes 600, then the profit, this 13,500, will become 600 multiplied by 30, that is 18,000. In the second case, 0, 0, we are not producing product B, so there will not be any change on the profit value. In the third case also, product B is not being produced. We are producing 30 units of product A and 0 units of product B. So if this 450 becomes 600, that won't bring any change in this value of 10,500. In the fourth case, when we change this 450 to 600, you find that the profit value will be 5,950. This is 350 multiplied by 17, that is equal to 5,950, plus 600 multiplied by 21 is 12,600. So the total profit is 18,550. You find that the total profit is still highest here compared to 18,000 or 0 or 10,500. 18,550 is higher. So still the maximum profit you are getting at 1721, and your optimal product mix doesn't change, it remains the same. Think about what will happen if the maximum profit value which you are getting, say 18,550 here, suppose you get the same value at some other point also, like this. In that case, it will be a special situation, and what happens, you can think about it in detail. We will discuss this in some other video.